Question number 7. A curve has equation y is equal to 2 plus 3 sine 1 over 2x for 0 to x lies between 0 to 4 pi. This is the interval, or it is given in radian because 0 to 4 pi. This is a trigonometric equation, trigonometric function y is equal to 2 plus 3 sine 1 over 2x. State the greatest and least value of y. To find the greatest and least value of y, first we write the equation in this form: y is equal to 2 plus 3 sine 1 over 2x. First we write it in this form: 3 sine 1 over 2x plus 2. This will be a sine wave, sine curve. This constant value 2 shows the baseline. If we add this baseline, this constant value, to the multiple of sine x, if we add these two values, constant value plus multiple of 3, that is 3, so we get the greatest value of the function. So greatest value of the function will be 2 plus 3, that is equal to 5. So graph will take the greatest value 5. So greatest value will be 5. Greatest value of the function. So if we subtract 3 from 2, we get 2 minus 3, that is equal to -1. This will be the least value of the graph. Least value of the curve, yeah, graph. Now next part of this question is sketch the curve. Sketch the curve. This is part B. So first of all, we have to sketch the graph of this function. 2 is the baseline, maximum point is 5, minimum point is -1. So we mention here, this is graph given on horizontal axis. There are values of the angles along y-axis. No value is mentioned on the along y-axis. So we mention here a suitable values: 0, 1, 2, 3, 4, 5, because the maximum value is 5. Minimum value is -1, so this is -1. So baseline, clearly this constant value shows the baseline. So we draw a line passes through 2. This is a baseline. Half graph will be on upside and half graph will be downward. This line is a baseline. Sine wave starting from 2, and the maximum point is clearly 5 and minimum point is -1. So graph will be we start from 2. This is the maximum point, and minimum point is -1 up to 4 pi. The period of this function will be, how we will find the period of the function. Look at this, sine 1 over 2x. So to find the period of this function, we divide 360 divided by this 1 over 2. that becomes 720 in 720 degree. Period is 720 degree, or in radian this means that 4 pi, or it is the graph is given up to 4 pi. This means that only one circle of the sine wave will be here. So we have drawn the graph from 0 to 4 pi because the period of this graph is 4 pi. There will be only one curve which we have drawn. This is the graph of the given function 3 sine 1 over 2x plus 2. So here we have to mention some important features of the graph. Important features mean the value against pi is clearly 5. If we put pi in the original equation here, this becomes 3 sine 1 over 2 pi. 1 over 2 pi means pi by 2, sine pi by 2 is 1. So 3 plus 2 is equal to 5. So here this is the important feature of the graph. Against pi, the graph will take the value 5. And maximum point we have mentioned, minimum point is -1 we have mentioned. And look at this, against angle 3 pi the value of the function will be -1. -1, if we can check 3 pi, if we put this 3 pi angle in the original equation in place of x, sine 3 pi by 2, that is sine 3 pi by 2 means 270. Sine 270 will be -1. So this will be -1. That makes this 3 -3. So 2 minus 3, that is -1. So this means that at 3 pi the function will take the value -1. These are the important features of the graph. And 4 pi is the end value. So we have drawn the graph from 0 to 4 pi. Now next part of this question, part C, is state the number of solutions of the following equation. 2 2 plus 3 sine 1 over 2x is equal to 5 minus 2x. These are two separate functions. This is a trigonometric function which is given, that is equal to y, but on the right hand side there is a linear function. There is a linear function 5 minus 2x that will make a line. Y is equal to 5 minus 2x is a separate function. This is a trigonometric function given. These are these two functions are equal, means we have to find the point of intersection of this line and this curve. Curve we have drawn already. We have to find the state the number of solutions of this equation. So first we draw the line. Clearly 2 plus 3 sine 1 over 2x is equal to y. So we can write that y is equal to 5 minus 2x, or y is equal to minus 2x plus 5. Now it is very simple that a line, we have to draw a line having y-intercept 5 but gradient is -2. Gradient negative shows that the line will make an obtuse angle with the positive direction of x-axis, and the y-intercept is 5. So we are drawing this line passes through 5, passes through 5, and gradient is negative. So this line will make an obtuse angle with the positive direction of x-axis. So this is the line. Now we are observing that there is only one point of intersection of this curve and this line. This is a curve and this is the line just we have drawn obtuse angle with the positive direction of x-axis passing through 5. Now it is very clear that there is only one point of one point, that is point of intersection of line and the curve, that is this point. This is the point of intersection. This shows that there is only one number of solution of this equation point, because only one point of intersection is there of line and the curve. So we write here the number of solutions 1. This is the answer.